Now, dear children, today I am going to tell about chemical reactions. Now, what is a chemical reaction? Chemical reaction is a chemical change. So, now chemical change, when we represent it by symbols and formula, that is known as chemical reaction. Now, what happens during chemical reaction? During chemical reaction, the chemical bonds between atoms or groups or atoms of reacting substances and there the rearrangement of atoms takes place. They form new bonds and by the formation of new substances, either release of heat or absorption of heat takes place. So, in this way, the chemical reaction it takes place. Now, there are reactants and products in chemical reaction. So, what are reactants and products? So, reactants, they are the substances that take part in a chemical reaction. Then the new substances which are formed because of the reactants, they are known as products. So now reactants, when they combine, the chemical reaction it takes place and so products are formed. Now, if we take example of a chemical reaction, like if I say potassium hydroxide reacting with sulfuric acid, this is the symbolic representation in the form of formulas and symbols you can see over here. Now, when they will react, products will be formed. Potassium with sulfate, it will form potassium sulfate. Hydrogen and hydroxide will form water. So now here we can see when the reactants they have combined, they result in the formation of products, sometimes one product, sometimes two products and sometimes more than two products. Now, what are the characteristics of a chemical reaction? There are many characteristics of a chemical reaction. How can we say that a chemical reaction is taking place? So, first one is evolution of gas. So, in many chemical reactions, the gas it evolves. We can take example of zinc plus hydrochloric acid. This is zinc. Word equation also I am writing plus hydrochloric acid After reaction, these are the reactants. After reactions, the products formed are zinc and chlorine will form zinc chloride, which is a salt, plus hydrogen gas, which is a gas. So here we can see that the reaction is resulting in the formation of a gas. Now balancing the equation, we have to balance the equation also. If I say 1 atom of zinc, here 2 atoms of chlorine, so we will be putting 2 over here. So now the equation is balanced, 2 hydrogen and here 2 hydrogen. Again, so now we will be putting 2 over here to balance the equation. So 1 atom of zinc, 2 atoms of hydrogen and here 2 atoms of hydrogen, 2 atoms of chlorine and here 2 atoms of chlorine. So now we will take another example, that is sodium chlorate. Now if we heat sodium chlorate, NaClO3. Now if we heat it strongly, we will be getting two products. First, the salt, that is sodium chloride, and other product, oxygen gas. Now the balancing part, that is 1 atom of sodium, 1 atom of chlorine, here 3 atoms of oxygen and here we are having 2 atoms of oxygen. So for balancing it, we will be putting 2 over here and this 3 we will be putting over here. So now the equation is perfectly balanced and we can see that the reaction is ending with the formation of oxygen gas. So now coming to the next characteristic, that is change of color. Now some of the reactions, they take place by change in the color of the reactants. We can easily characterize them by the change in the color of the reactants. So second characteristic, change of color. Now in this we can take example of iron plus copper sulfate. Here we can see we will take the aqueous, means the solution of copper sulfate. Here we can see that it will result in the formation of the product, that is FeSO4, that is iron sulfate, and plus copper. Here we have put pieces of iron in the solution of copper sulfate, that is blue in color. So the product we will be getting, that will be iron sulfate. Now the blue color of copper sulfate, it will be get faded and it will be turning into light green color. With the formation of iron sulfate, because the iron is light green in color, so the solution, the color of the solution will change from blue to light green. So in this way the change in color takes place. Now another example also we can take by taking the example of copper sulfate that is the solution of copper sulfate, which is blue in color, where it will react with hydrogen sulfide gas. So the resultant product will be copper and sulfide will combine to form copper sulfide, plus hydrogen and sulfate will form sulfuric acid. So now the blue color of copper sulfate will result in the formation of black solid, that is your copper sulfide. Now the color will change from blue to black because of the formation of the product, that is copper sulfide. Now coming to the next, that is formation of precipitate. So in the word equation form, we can write it as copper sulfate plus hydrogen sulfide resulting in the formation of copper sulfide, that is black in color, plus sulfuric acid. Now, next characteristic of a chemical reaction is formation of precipitate. Precipitate we always show by the downward arrow. So some of the chemical reactions, they take place by the formation of precipitate. Precipitate, they are insoluble solid. In short form we write it as PPT, that is your precipitate, and that is your insoluble solid. Now, these insoluble solid, they settle down at the bottom of the test tube in which the reaction is carried out. So in this we can take example of silver nitrate solution. Silver nitrate. Now how do we write the formula of silver nitrate? Silver is Ag 1 plus and nitrate is NO3. So silver nitrate solution plus sodium chloride solution. We write over here aqueous, that means mixed in water. Now in word equation also I am writing silver nitrate plus sodium chloride resulting in the formation of silver will combine with chlorine, and that it will be resulting in the formation of silver chloride, that is your precipitate, plus sodium nitrate. Now NaNO3. Now silver chloride is your precipitate, that is white in color. Here I am writing in the word equation form also silver chloride, which is a white precipitate plus sodium nitrate solution. Now, after that, one more example we can take here where the formation of precipitate is taking place, that is barium chloride. Barium is your 2 plus, chloride is yours 1 minus. So the formula is barium chloride, for barium chloride is BaCl2 plus sulfuric acid. Now after reaction we will see that this is the in the solution form, barium chloride in the solution form, barium chloride, that is in the solution form, plus sulfuric acid so it will be resulting in the formation of barium sulfate. Barium Ba is 2 plus and sulfate is your 2 minus. So it will be resulting in the formation of barium sulfate plus hydrogen and chlorine. It will be forming hydrogen chloride. Now here barium sulfate again is a precipitate represented by downward arrow. So barium sulfate, it will be a white precipitate. Now coming to the next characteristic, that is change of the state. Many chemical reactions, they take place by changing of the state. Now in this, the physical states in a reaction that we always represent by S for solid state, L for liquid state and G for gaseous state. S for solid state, L for liquid state and G for gaseous state. So taking one example, that is ammonia, that is a gas, plus hydrogen chloride, that is also a gas, resulting in the formation of a solid, that is your ammonium chloride. Ammonia and hydrogen will form a radical, that is ammonium NH4 1 plus and chloride, so Cl1 minus. So it will be forming a solid, that is ammonium chloride. Ammonium chloride, and this is solid. So here we can see that ammonia is a gas, hydrogen chloride is a gas. When both of them they react, they result in the formation of a solid, that is your ammonium chloride. Now another characteristic of a chemical reaction is change in energy. Now some of the reactions, they take place by change in energy, where the energy released is in the form of heat and light. Now what are the conditions which are necessary for a chemical reactions? Conditions which are necessary for a chemical reaction. So there are many conditions which are required for a chemical reaction. They are close contact. When the reactants they are in the close contact, the reaction takes place between them. Like potassium plus water. Potassium is very reactive element. It reacts with cold water and gives product potassium hydroxide plus hydrogen. So here we have to balance the equation also. So we will be balancing the equation. So we will be getting the product. So how we are getting these products? When these reactants are kept in close contact with each other. Now second condition is that attraction in the physical state of the reactants. When the reactants they are in the solution form. So now if I take example of sodium chloride solution, that we write over here aqueous, that means in the solution form, sodium chloride plus silver nitrate, that is also in the solution form. They will react to give, see the here the exchange of radicals takes place. Sodium will be forming compound with nitrate and silver with chloride. So silver chloride plus sodium nitrate. So this is a precipitate, silver chloride plus sodium nitrate. So now this reaction is taking place when the reactants they are in the solution form. So the attraction in the physical state of the reactants takes place. Then heat. Now we can see that some of the chemical reactions, the third point is heat energy. So some of the chemical reactions they take place only in the presence of heat. Now in this we can take example of copper nitrate. Copper is Cu, nitrate is NO3. So Cu2 plus and NO3 1 minus will be CuNO3 whole twice. So copper nitrate. So the reaction will only take place, it will decompose only in the presence of heat. So products which we will be getting over here will be copper oxide plus nitrogen dioxide, which is a gas, plus oxygen. Copper oxide plus nitrogen dioxide plus oxygen. So this reaction will take place only in the presence of heat. So these reactions are there which are taking place in presence of heat. So again we will be taking more example, that is powder of iron and sulfur both in the powdered form. When we react them both in the powder form, iron and the sulfur, they will not react to give any product. But when we supply heat, this is your iron and this is your sulfur, both in the powder form I said just now. So when heat is supplied, it will form a product, that is iron sulfide. So this reaction is only possible in the presence of heat. Now light energy. Some of the reactions, they take place only in the presence of light, and so we call them as photochemical reactions. Photochemical reactions. The reactions that take place only in the presence of light. So here we can take one of the most common example, that is photosynthesis. So photosynthesis, carbon dioxide plus water, this is your carbon dioxide and this is water. It will react in the presence of sunlight and chlorophyll to give glucose, that is C6H12O6 plus oxygen. This is your glucose and this is oxygen. So here by balancing the equation we will see giving glucose and oxygen gas. So this reaction, we can see that this reaction is only possible in the presence of light. So light energy also plays very important role in the chemical reactions. Then electricity. Some of the reactions, they take place in the presence of electricity only when the electric current is passed through them. One of the most common example here we can see is the decomposition of water, that is acidified water. When we pass electric current through acidified water means water plus acid. Dilute sulfuric acid we mix to make water in an electrolyte, because water is not a good conductor of electricity. So when electric current is passed through water, it decomposes into its elements, that is hydrogen and oxygen. So this is water, acidified water, this is your hydrogen gas and this is the oxygen gas. Now coming to the next, that is your pressure. Some of the chemical reactions, it takes place in the presence of pressure, like nitrogen reacting with hydrogen. This is a reaction which takes place in the presence of temperature 450 degrees Celsius and 200 atmosphere, that is your pressure, to form ammonia gas. This is your nitrogen plus hydrogen, giving two molecules of ammonia gas. Again, balancing the equation. Now, catalyst. Some of the chemical reactions, they take place in the presence of catalyst. Now, what are catalysts? Catalysts, they are the substances which either increase or decrease the rate of a chemical reaction. So there are two types of catalyst. First one is your positive catalyst, which increases the rate of reaction, and another is the negative catalyst, which decreases the rate of chemical reaction. Thank you, dear children, for watching this video. Listen and see carefully. Thank you very much.